In this video, let's do a couple of game theory examples. Got a couple of problems here with payoff matrices. All right, so first problem was actually two games. Game one and game two. GM and Chrysler must decide whether to invest in a new process. Games one and two show how their profits depend on the decision the other might make. So they are interconnected. They are an oligopoly. Here we go. Okay, so let's do Chrysler in red and GM in blue. And what we want to do is we want to say here are their two, these are called strategies. So it's invest or don't invest, invest or don't invest. And then these are the payouts. Okay, now this one is written, it's a little more confusing. I grabbed it this way just to have it, but you could maybe draw the rest of the box in there so it looks a little more consistent for you. You can always do something like this if you run into something that looks like you're not used to. Okay, so all right, so let's do GMs first. Okay, so let's say that Chrysler invests. What would be better for GM? Would it be to invest and get 5? Or would it be don't invest and get 4? Well, it'd be better to invest and get 5. So I'm going to underline it because I don't have another option for the other company there. And then if Chrysler doesn't invest, what's better for GM? To invest or don't invest, because they would get 12 or 10, and it'd be better to invest. I'm going to go ahead and circle that. Okay, so already it didn't ask us for this, but in case it does, GM has a dominant strategy to invest. Okay, so now let's go ahead and solve Chrysler's decisions. Okay, so let's say that GM invests. What's better for Chrysler, 5 or 4? And it's better to get 5. So 5 is better than 4 there. And then if GM doesn't invest, it's better for Chrysler to get 12 instead of 10. So I'm going to go ahead and take that one. Okay, so Chrysler also has a dominant strategy, and then the Nash Equilibrium here, I'll do this one in purple, is that they're both going to invest. So that's the answer to that first game. Let's do the second game. I'll do this rather quickly. There's Chrysler. There's GM. Okay, so if Chrysler invests, it's better for GM to invest. And if Chrysler doesn't invest, it's better for GM to invest. And if if GM invests, what's better for Chrysler? Well, it's better to don't invest. And then if GM doesn't invest, it's better for Chrysler not to invest. So the Nash equilibrium is the place where we circle both of these. And in this case, this one's a little different. This is going to be written as GM's going to invest, Chrysler is not going to invest. Okay, so that's the answer to that one. Which of the game represents a prisoner's dilemma? So prisoner's dilemma is a situation where both parties, by choosing the competitive outcome, end up worse off than if they would have cooperated. So in the first game, they both get 5. Those two would be better for one party but not the other. But this is actually the best outcome right here, where they both got 10. Okay, well, they're not going to pick that. So definitely game one is prisoner's dilemma, because they're going to end up competing, both investing, and end up with the worst payoffs. Game two, let's see if that is... Game two is not a prisoner's dilemma, because they didn't result in this right here. They ended up in a better situation. In fact, the one where they've kind of maximized the payoff. So it's just game one. Okay, let's do this other problem. I've got Goodyear. We'll do them in blue this time, and Firestone. We'll do them in green. Here we've got pricing. This is called a pricing game. Okay, so if Goodyear can choose a price of $100 or $60, Firestone $100 or $60, they're selling tires. Pretty similar product. Okay, this time I'm going to do Firestone first. So if Goodyear chooses 100, what's better for Firestone? So the F is going to refer to Firestone. the G is going to refer to Goodyear. So what should Firestone pick, 100 or 60? If Goodyear picks 100, well, it'll be better to get 33 than to get 20. And then if Goodyear chooses 60, then it's 12 or 11, so I'm going to choose 12. Okay, then let's go to Goodyear. Goodyear, if Firestone chooses 100, what's better for Goodyear? And that would be to choose 100 because they would get 36 instead of 35. And then over here, if Firestone chooses 60, then Goodyear wants 30 instead of 10. Okay, what, if any, is Goodyear's dominant strategy? So a dominant strategy is a set of choices that they're going to pick regardless of what the other player does. Well, in this case, they both have what's called a mixed strategy, so their decision is going to depend on what the other party is going to do. So for example, if Firestone knows that Goodyear is going to pick $100, then they're going to go ahead and pick 60, and then we'd end up right here. Okay, so this would be like if they if one player moved ahead of the other player, right? Or if Goodyear knew that Firestone was going to pick 60, then they could go ahead and pick 60, and we'd end up right there. Okay. What, if any, is the Nash equilibrium? Well, there isn't a Nash equilibrium, and there doesn't have to be. So that's how to solve two of those games using a payoff matrix. They look a little bit different, so that's why I did those.